You know that we use the word cube in geometry. Do you remember what a cube is? Yes, a cube is a three-dimensional figure with six square faces and each edge of the same length. What is the volume of a cube with side A? Yes, it is A multiplied by A multiplied by A. Just like this, in algebra, cube of a number is obtained by multiplying the same number three times. For example, cube of 2 is equal to 2 into 2 into 2 equal to 8, and of 3 is 3 into 3 into 3 equal to 27. Let's study about a perfect cube. It is a number which can be obtained by cubing a natural number. For example, 8 is a perfect cube, as it is obtained by cubing 2. 27 is a perfect cube as it is obtained by cubing 3. Let's calculate cubes of some numbers. Let's start with 4. What will it be? To calculate cube of 4, we will multiply 4 3 times. Therefore, 4 cube is equal to 4 into 4 into 4. 4 into 4 is 16, and 16 into 4 is finally 64. Try the next on your own. 5. So, cube of 5 is 5 into 5 into 5, is 125. Let's see a different type of question. If you calculate the cube of any number, which has 1 at its ones place, what do you think will be the digit on ones place of the cube? Correct, it will be 1. Similarly, if you calculate the cube of any number, which has 2 at its ones place, it will have the digit at ones place equal to 8. So, the digit at the ones place in the cube of any number is equal to the cube of the digit at the ones place of the original number. Let's try a question. Find the ones digit of the cube of each of the following numbers. 31. Yes, the answer is 1. Because the digit at ones place of the number is 1 and the cube of 1 is equal to 1. Let's confirm by calculating its cube. So the cube of 31 is 31 into 31 into 31, which using calculator comes out to be 29791. Now let's try 53. What do you think is the answer? What is the digit at ones place of this number? It is 3, and what is the cube of 3? Yes, it is 27. So, what will be the answer? Yes, the digit at ones place is 7. Now moving on, let's see some interesting patterns. The first is adding consecutive odd numbers. Let's observe. This is the list of consecutive odd numbers. Let's take 1 first. 1 is itself a perfect cube. Next, we take the next 2, 3 and 5. The sum is 8, and it is a perfect cube of 2. The sum of next 3, 7, 9, 11, comes out to be 27, and it is also the cube of 3, and hence is a perfect cube. The second pattern is about cubes and their prime factors. Consider the following prime factorization of the numbers and their cubes. Each prime factor appears 3 times in its cubes. Now, we'll see how to judge whether a number is a perfect cube or not. Is 216 a perfect cube? Let's do it together. First step is to make prime factors of the number, that is, 216 divided by 2 is 108, divided by 2 is 54, divided by 2 is 27. 27 divided by 3 is 9, divided by 3 gives us 3. So, we get the prime factors of 216 equal to 2 into 2 into 2 into 3 into 3 into 3. So, let's check if 216 is a perfect cube or not. It is a perfect cube. Why? Because, in the prime factors of 216, we observe each prime number occurring in the multiple of 3 times. 216 is equal to 2 cube multiplied by 3 cube. So, to check whether a number is a perfect cube or not, always make prime factors out of it, and then judge. Let's try checking 392 also. First, Let's find prime factors of 392. 392 divided by 2 gives 196, divided by 2 gives us 98, divided by 2 gives us 49. 49 divided by 7 gives us 7. So, the prime factors of 392 equal to 2 into 2 into 2 into 7 into 7. Is it a perfect cube? Let's check. The first factor, 2. How many 2 are there? Yes, there are 3 in number. So, it passes the criteria. The second factor, 7. How many 7 are there? Yes, there are 2 in number. So, it fails the criteria. This implies 392 is not a perfect cube. Now, we have a question. What smallest number to multiply with 392 to make it a perfect cube? Can you think of any number? Yes. It is 7. We need to multiply 7 into 392 to make it a perfect cube. How did we see it? Because 7 was the number which did not pass the criteria, and it was 2 in number, rather should be in multiple of 3. So, the minimum number we can multiply in 392 to make it a perfect cube is 7. Next concept we have is cube roots. Imagine you have a cube. Volume of the cube is 125 meter cube. You need to find the length of the side of the cube. We know the formula for the volume of a cube, that is, side cube. To find the length of the cube, we need to know which number has its cube equal to 125. So, we need to find the cube root of 125. And the number whose cube is equal to 125 is 5. So, cube root of 125 is 5. So, cube root of number is a value which when multiplied by itself thrice or 3 times produces the original value. Let's find the cube root of 3375. Again, the first step is factorization. Let us factorize 3375. 3375 divided by 3. We get 1125 divided by 3 gives 375, divided by 3. We get 125. 125 divided by 5. We get 25 and divided by 5 gives 5. So the prime factors of 3375 are equal to 3 into 3 into 3 into 5 into 5 into 5 equal to 3 cube into 5 cube. Now, to get the cube root, we remove the 3 from the powers of the numbers. So, we get 3 into 5. That is 15. This implies cube root of 3375 is equal to 15. We hope that you have understood the concept of cubes and cube roots. Now, here's a secret on how you can study effectively with the EduRev app. You can learn with chapter notes, watch video lectures, and solve NCERT-based MCQ tests of this chapter on EduRev. And that's not all, you also get amazing courses for Class 8 and much more for your Class 8 preparation. Thank you.